This is second in a series on scientific notation. This one is operations with numbers expressed in scientific notation involving real-world problem solving. Let's take a look at a few problems. The den in Macy's house is approximately 1,400 cubic meters. If we know the number of dust particles per cubic meter, and there it is, how many dust particles will be in Macy's den? So we convert the 1,400 cubic meters to scientific notation, 1.4 times 10 to the third cubic meters, and we're going to multiply the number of dust particles per cubic meter times the cubic meters in Macy's den. So here we set up our problem. Now we're going to use the distributive property. Then we do the multiplication. And we know when we multiply exponents that we add them. So we end up with 4.76 times 10 to the 12th. The volume of Lake Bloud is about 3.24 times 10 to the 5th kilometers cubed, which is 15 times the volume of Lake Winder. What is the approximate volume of Lake Winder? So we set up our problem, and we know that 15 times 15 in scientific notation is 1.5 times 10 to the first. So we're going to multiply, and again we use the distributive property. 1.5 times 3.24, we end up with 4.86, and then we're going to have the other factor keep the base and add the exponents. 1 plus 5 is 6. Our final answer is 4.86 times 10 to the 6 kilometers cubed. Researchers have found the skeletal bones of adult human males consist of 3.8 times 10 to the 4th pounds of calcium. And the female adult bones, skeletal bones, consist of 4.1 times 10 to the 4th pounds of calcium. How much more calcium does a female skeleton have than the males? We know when we see how much more that indicates subtraction. So we set up our problem. We have the female and then we have the male. And we again use the distributive property. So 4.1 minus 3.8 gives us 0.3, and since our factor in both is the same, 10 to the 4th, and that's what we want, we can't subtract unless they are the same, then we're just going to multiply times 10 to the 4th. 0.3 times 10 to the 4th, yes, that is the answer, but we want it in proper scientific notation, so we have to move the decimal point over 1, and when we do, we end up with 3 times 10 to the 3rd. So if we move to the right with the decimal point, we need to decrease the exponent by 1. The population of a large metropolitan city was approximately 4.5 times 10 to the 6 in the first year a census was taken. It grew by 2.6 million when the third census was taken. What was the population of this city reported on the third census? Well, if it grew by if it increased by 2.6 million, then we know that we're going to add. So 2.6 million equals 2.6 times 10 to the 6. So we set up our addition problem. Again, we're going to use the distributive property. We see that our two factors here are the same base and the same exponent, so we can just multiply times 10 to the 6. When we do our addition, 4.5 plus 2.6, we get 7.1 times 10 to the 6. So that would be the reported population on the census, the third census that was taken. Okay, the population of the United States is approximately 3.3 million. Population of China is approximately 1.4 times 10 to the ninth. About how many times larger is China's population than that of the United States? How many times larger we're going to need to divide? So 3.3 million, we put that in scientific notation, we get 3.3 times 10 to the 6th. We already have China's population as 1.4 times 10 to the ninth. We set up our division problem, and then we do the division. We divide 1.4 by 3.3, we end up with 0.42, and we know when we divide with exponents that we subtract. So we're going to keep the base and subtract, and so that is times 10 to the third. Well, once again, that is a correct answer, but we need that we need to expand it in order to answer the question. So when we do, for 0.42 times 10 to the third, we move a decimal point over 3 places, and we find that it is 420 times larger. Okay, that ends this video on operations on numbers written in scientific notation, real-world problem solving. Enjoy the activity.